Okay, so this is the Gamecocks drone service problem for DRM. We are the DRM group. As you can see, a very creative name. Uh, the group includes Blake, Kieran, Nicholas, Shreve, and Tim. Okay, so the problem. You guys know this, but I'm going to go over it quickly. So the metropolitan area is covered by GDS package delivery service. They've been very inefficient and don't really have any kind of plan as to what they're doing. They deliver 1,250 small packages a day to 10 different cities using 10 drones. So 125 drops per city, so that'd be per drone. So our group has been tasked with coming up with a viable strategy to cut down on inefficiencies and discover the most optimal route. And that's what I'm going to do right now. So I'm just going to take you through our calculation here. So using Excel, we first numbered each drop point from 0 to 125, which we listed in a column adjacent to the X and Y coordinates, as you can see here. We then took the coordinates and adjacent numbers and created a matrix. We listing these points across the 3 different rows, both on the X and Y coordinates, and on 126 different columns. So using the square root function, we calculated the distance between all 127 points, including the beginning and end points at headquarters, which goes all the way down. Our calculations of the matrix across all 126 points assisted in the next steps, including our search for the shortest distance between 2 different points. So I just want to say real quick, so this square root function is basically use of the Pythagorean theorem. So we did all this, did the calculations, that brought us down to the next point. Right here. So we included a 0 at the beginning and the end, which we'll see in a second, of our numbering because these zeros served as our representation of the drop points for headquarters. And the reason we did that, these served as both the endpoints in our data. Below each of these numbers, we also ran a search to find the shortest distance between 2 different drop points. To do this, we used the index function to search each individual row and match it with its respective column. Each calculation included a +1 in our algorithm because we wanted to search points starting at HQ, which was represented by 0, so you had to do a +1 to actually make the function work. Once these calculations were complete for all points, our next step was to determine the optimal order or shortest total distance between these drop points. To do this, we decided to run the solver function to search for the shortest distance between all points, excluding headquarters. We decided to exclude headquarters and only focus on the coordinates for drop points from 1 to 125 because these were our start and end points in the delivery routes, and including them, the headquarters were the start and end points in our delivery routes, and including them would have skewed our data and also mixed them into the ordering, which would have given us inaccurate information since they were the starting and ending points. So really quick, I'm just going to show you what we did in Solver. Minimum route from here all the way to the end, excluding the zeros, basically is what it is. So pretty simple. Show you what we did. Down here. To ensure our results were accurate and we had achieved our lowest score possible, we ran the solver function 10 separate times, even going so far as to use different team members' computers and different Excel charts with new separate runs through the algorithms and functions. Once the drop points were organized by shortest distance between 2 points, we totaled the distance using a sum function. And it wasn't until the last few tries that we reached our consensus in our results, and 450.88 was the optimal run, the shortest distance that we could get. So that is the answer, for us at least. Take you back here. So solution. Just recap. Basically, traveling salesman problem, but with a twist. You have a fixed starting and ending point, which is headquarters, which was 0. We created a matrix in Excel and calculated the distance between them using square root, which was a Pythagorean theorem. Using index function, we search each individual row for the shortest distance between 2 different points and match it with the respective column. Each calculation needed to be have a +1 because just the 0, headquarters start, and that allowed us to use the Excel. That was more of an Excel problem than the actual problem itself. We then calculated the shortest distance using Solver, and our most optimal route was 450.88 miles. Our team was Blake, Karen, Shreve, Nick, and Tim. And thanks for watching the video. We hope you found it enjoyable.